Dear students, today I am going to discuss on the topic Pleistocene climatic conditions, its causes and evidences. Now let me introduce about this topic. The Pleistocene epoch is one of the important landmarks in the history of human civilization. It is the period of climatic fluctuation. The most striking feature of the Pleistocene epoch was the slow lowering of the temperature of our planet, the Earth. At various times, much of it was covered by a vast sheet of ice known as glaciation, and it was extremely cold and varied from dry to wet. Earth scientists as well as prehistorians tried to find out the causes and recover the evidences of the occurrence of the Pleistocene climatic conditions, particularly geological evidences of the glaciations. Now let's come to the next point, causes of glaciation. Pleistocene was an epoch of great climatic fluctuation. Those fluctuations occur repeatedly at frequent intervals and produce dramatic changes in the deposition of water level. The exact reason behind this situation is not known, but attempts have been made to explain it. Two types of theories are found in this context. They are astronomical and geographical, that is, plate tectonic. Now let's move to another point, that is astronomical theory. There are several types of astronomical theory about the causes of ice age, which fall generally into the following categories. Number 1. Increased concentricity of Earth's orbit. Number 2. Change in the intensity of solar radiation. And number 3. The Earth passing through cold regions of space. And lastly, number 4. Ice dumped directly from the space. There are two opinions. One is a hypothesis and the other one is a theory to determine the cause of Pleistocene climatic change. These are, number 1 is Crowell's hypothesis and number 2 is Simpson's theory. In the 19th century, James Crowell published the calculation of how the gravitational pulls of the Sun, Moon and planets subtly affect the Earth's motion and orientation. The idea of Crowell was further developed later by Milutin Milankovic. He worked out the ideas of climate cycles in 1920s and 30s. To test the hypothesis adequately, he worked out on the detailed chronology of the quaternary temperature change. A problem with the hypothesis is that astronomical cycles have been in existence from billions of years, but glaciation is a rare occurrence. Astronomical cycles perfectly explain glacial and interglacial periods and their transmissions inside an ice age. Other factors must be involved, the cause of Earth's temperature to drop below a critical threshold. Once that occurs, Milankovic's cycle will act to force the planet in and out of glacial periods. In the 1930s, Simpson published a number of papers that speculated on the feedback mechanism that would be triggered by change in the atmospheric concentration of carbon dioxide. In 1934, he suggested that an increase of solar radiation might bring some changes on an ice age. His reasoning was that a rise in sun's radiation would warm the equator more than the poles, evaporating more water from the tropics and increasing the rate of the general circulation of the atmosphere. This would bring more snowfall in the higher latitudes. Snow that would accumulate into ice sheets. The albedo of the ice sheets would cool the poles. Furthermore, the ice which enters the sea from these regions will have a large effect on the remote regions, cooling the entire hemisphere. Now come to the next point, geographical theory, that is plate tectonic. The theory is based on geographical changes that occur in the earth at the close of the Tertiary period. It advocated a drastic alteration of climatic conditions. According to T.C. Sharma in 1974, in the Pleistocene age, ice sheets originated at the poles. The movements of Earth's plates on plate tectonic also appears to play a role. The position of a continent affects its climate. The landmass at high altitudes are more likely to be cold and provide the conditions for glaciers to form. The changes caused by plate tectonic also include uplift brought on by plate collision, mountain ranges formed by overriding each other, and oceanic ranges created by plates moving away from each other. These movements allow some changes on Earth's composition and could bring some changes on the climatic condition, which is conducive to an ice age. The lithosphere plates continued to shift during the Pleistocene, but continents essentially were in their modern position. At this part of the epoch, the more importance to subsequent quaternary events was the late tertiary movements that affected the evolution of climates towards that of the quaternary. Now come to the next point, evidences of glaciation. The Pleistocene epoch is a period of radical climatic fluctuation, and this is supported by different geological evidences. Among the evidences, mention may be made of the presence of moraines, river terraces, loess, sea level changes, raised sea beaches, and soil creeps. Among these evidences, river terraces are considered to be archaeologically significant because these occur in stratified condition, while the remaining other evidences occur in unstratified position. Here our main concern is on moraines, river terraces, and sea level changes. Now come to the next point, moraines. The moraines are special glacial deposits. Moraine material is transported by a glacier and deposited. They are unstratified deposits of many materials or soil, pieces of stones or boulders, stone tools or any other artifacts that accompanies the glacier in their journey on slopy paths. In other words, the glacier, wherever they find some slope, they used to advance, and in the wake of their movement carried many sundry objects or materials. 6 types of moraines have been identified by Whelan in 1945, which were found to be effective to form recognizable landforms and thus stand as evidence of glacioclimatic fluctuation during the Pleistocene. The 6 types of moraines that are responsible for shaping the landforms are ground moraines, lateral moraines, medial moraines, push moraines, recessional moraines, and terminal moraines. Now let's come to the next point, river terraces. Fluvial sequences, particularly terrace staircases, represents archives of tertiary paleoclimatic fluctuations and serve as stratigraphical framework for geochronology and for correlation with depositional environment, particularly the global marine oxygen isotope record. They provide context for records from fossils and artifacts of faunal revolution and human occupation. Conversely, both records can be the means of relative dating of riverine sequences. River terraces are topographic platforms, benches or steps in the river valley that represent former levels of valley floors and floodplains. Throughout much of the world, beach lines and river terraces were formed during the glacial period. At present, they lie above the sea level or river floodplain. Formation of major river terraces was the result of high fluctuation of water level in rivers due to glaciations. During these periods, all the available moisture used to be frozen into ice, thus decreasing the quantity of water. With the onset of interglaciations, temperature used to increase, resulting in the production of more meltwater. It accelerated soil erosion and made newer terraces in the process. During the Pleistocene period itself, in the tropical regions, that is in contrast to glaciation, the increasing rainfall, that is pluvials, and decreasing rainfall, that is interpluvials, affect the velocity of the rivers, helping in the formation of terraces like glaciation and interglaciations do. The material of the terrace is laid down during the aggradational period. The axial terrace is formed only when erosion takes place. In this way, erosion and aggradation make several steps or levels or terraces along the river. Generally, the highest terrace is the oldest, while the lowest would be the youngest. The lithic tools found on various terraces thus could be dated depending on the study of various terraces. Now let's come to another point, that is river terraces versus morons. In archaeological terms, river terraces were more important than the moraine deposits because river terraces are stratified. Thus, cutting the steps or levels or terraces in longitudinal cross section would give the sequence of cultures deposited there. On the other hand, the moraine deposits are unstratified and sometimes mixed. Hence, they do not help the prehistorians to get the fairly correct idea of cultural sequences accumulated there. Now let's come to another point, that is sea level changes. Coastal environments during the Pleistocene were controlled in large part by the fluctuating level of the sea as well as by the local tectonic environmental conditions. As a result of many glaciations on land and the subsequent release of meltwater during interglacial times, sea level has fluctuated almost continuously between interglacial levels like the present day. During maximum glaciation times, about 18,000 years ago, sea level was more than 100 meters lower. At that time, all the continental land areas were larger. Extensive areas of world's continental shelves were exposed to weathering. Soil formation, fluvial and aeolian activities, and these areas were inhabited by plants and animals. The Bering Shelf was exposed at this time. Thus, Siberia was connected to Alaska by land bridge. It allowed intercontinental migration of animals, including early humans. Rapid melting of the last ice sheet resulted in rising sea level that reached near modern level by the mid-Holocene around 5,000 years ago. As a consequence, Pleistocene coastal environments were submerged below the sea level in most parts of the world. Carl W. Budger termed this effect of glaciation as glacio-eustatic change in 1971. Fortunately, some coastal areas of the world were undergoing tectonic uplift during Pleistocene period. As a result, older shorelines and their deposits were exposed above the modern sea level. The highest sea level prior to the modern level occurred around 125,000 years ago. Sea level at that time was about 6 meters higher than it is today. Now let me come to the concluding remark. During Pleistocene period, the climatic condition was extremely fluctuated. These fluctuations were caused by different agencies like increased concentricity of Earth's orbit, change in the intensity of solar radiation, the Earth passing through cold regions of space, and lastly, ice dumped directly from the space. Such climatic fluctuation and environmental changes were evidenced by morons, river terraces, sea level changes, etc. Thank you all.